So for our next word problem regarding addition of vectors, an airplane is traveling due east at a speed of 700 miles per hour. The wind is blowing at a speed of 80 miles per hour and at an angle of 60 degrees east of south. Determine the speed and angle of the plane. So first we're going to represent it into the Cartesian coordinate with plane. So number 3. So we're going to draw our Cartesian coordinate plane here. South. And observing the cardinal directions. 700 miles per hour due east, so this is the east direction, so we draw it like this, 700 miles per hour. The wind is blowing at a speed of 80 miles per hour at an angle 63 degrees east of south. So basically what we practiced before, off south, that would be the first thing we have to consider. So off south, let's refer to the south part first. East of south, which here is the east part of south. Is it this or this? Obviously it's this because it says east. So so this is the east part of the vector here. It's east of south. So now east of south. So south east. So it's gonna be going from here, and then east of south is heading towards that direction. So we're gonna point there. So the angle we're gonna refer here is this one. 63 degrees actually. 63 degrees at 80 miles per hour. So now, to find the resultant vector, we basically do the same thing as we did a while ago. So that we don't get confused, we could actually just separate these two vectors. I'm going to separate the wind vector here, 63 degrees, 80 miles per hour. So now we're gonna try to get the components of the 700 miles per hour first. So okay, here's what we need to take note. 700 miles per hour to east. There's no specific angle. You know, it's just the x-axis. So what do? It's just 700 miles per hour. So that's the vector. 700 goes 700 and 0. That's the component of the vector. We don't need to break it down anymore. And even if we did break it down, it's gonna be the same. Okay, so basically this is 0 degrees here. So even if we try 700 cosine 0, 700 sine 0, it's still gonna be the same. 700 cosine 0, 700, it says 700 here. 700 sine 0, that's just gonna be 0. So, that's a trick we can use for addition of vectors. And now, for this one, in regards to the wind, this is where we're gonna have to use our cosine and cosine formulas properly. So always take note that the angle that we're referring to when using the sine and cosine formulas, or basically the analytical method, starts from here of the Cartesian coordinate plane. Now this one is 90 degrees, this is 180 degrees, and finally here 270 degrees. Now if this entire portion here is 270 degrees and this one here is 63 degrees, what should be the total angle from here up to here? 270 plus 63 degrees. I'm just gonna make sure I'm actually correct because I'm an overthinker. Plus 63, 333 degrees. 333 degrees. So using that for our formulas, so we start with the magnitude first. 80 cosine 333, 80 sine 333. There we go. I'm just gonna write it here. 80 cosine 333, 80 sine 333. So now 80. So let's type that in the formula. 80 cosine 333, 71.2805, 71 rather, 71.2805, and sine negative 36.319. Yeah, that is our x and y components, and representing that vector into component form, 71.2805 negative 336.319. Let's just write this 3192 because you have to calculate. That's what the calculator says. just to make sure and minimize the margin of error, because decimals, I'm kind of weak on that. So now, since we have each vectors in component form, just add them up really. So 700 plus 71.2805, we add up the x components of each component form of the resultant vectors. So 700 plus 71.2805, we can just do that. So 771.28005 comma negative 36, because this one is just 0 here, so we don't really have to do anything, just copy it. 192. Okay, now that we have that, we just substitute it now into the Pythagorean theorem. 2805 squared plus negative 36.3192 squared. Now typing that, 771.2805 squared plus negative 36.3192 would give us 772.1315, or we can just say 772.1352, because this is 5 here for our 5th decimal place, and for our 4th it's gonna be 2 now, because 5, we're actually gonna have to increase the number by 1. There we go, I got it. Decimals, rounding off, it's my weak spot. So that would be our that would be the magnitude of our resultant vector, which is 772.1352 miles per hour. And we're not done, because we need to determine the angle as well, or basically the direction. So now, as we can see here, the signs of the components are positive and negative. And now, referring to our butterfly method, because it looks like a butterfly and we can use it easily, positive and negative refers to the 4th quadrant. So basically, this will be the angle that we're going to be finding. Now, why do I use this? You might be asking, hey, why are you using this method? Because it helps me, for me at least, but I want to share it. It helps me determine how exactly we're going to find the angle from this point to that point. And since we know the position of this angle right here, we're going to find out, it's in the 4th quadrant, and this is the angle. So basically, we know this 90 is 180 to 70, and basically we can just find a way to find the angle from here to here. That's what I do, so I kind of just wanted to share it as well. So now, using the formula, negative 36.3192, basically the y component over the x component, 771.2805. Now, I can't find my calculator. Wow. Okay, here. Tangent, -1, negative 36.3192 all over 771.2805 is equal to negative 2.69603. Negative 696.03 degrees. Now that is the angle here. So now we're gonna have to find the angle from here up to there. Basically this one. That one of the resultant vector. So now, basically, we could just ignore the sign and say this 2.69603 degrees, because if we separate it anyway, if we extract it and make it into an independent right triangle, that's what happens. And then now, we're gonna try to find out the angle. So now, when we're gonna refer to the coordinate plane again, this entire segment here, basically this entire thing is 360 degrees here. Yeah, that entire circle here. Now if this one is 2.69603 degrees, 04 degrees here, this segment, what would this segment be? So this 90, 180 to 70, then another segment here. So basically all we're gonna have to do is you know, add that up, add this and this unknown angle here, which is, let's just call this unknown angle x, and that should equal to 360. So 2.69603 plus x is equal to 360 degrees. Minus both sides by 2.69, so 360 degrees minus 2.69603 equals, basically just add 357 degrees. 7.304 degrees. And yeah, that's our final answer. That would be 772.1352 miles per hour. And at an angle of 357.304 degrees here.